Data are everywhere. In the watch that tracks your heart rate, usage clicks, and within the survey that highlights health disparities in minority populations. Data can show us trends that highlight our greatest needs and bring our story to life. Ultimately, it can inform our decisions to implement positive change to our workplace, communities, and beyond. Data can also be unwieldy and unreadable because of mismanagement. Software can become obsolete, data can degrade, and files can get lost without preparation and planning. In today's video, we will define data terminology and look at how managing data through the research data lifecycle can benefit your project. Let's get started. There are many definitions regarding data and metadata, but for the purposes of this video, we will keep it simple. At its most basic definition, data are information. Usually, this information is a fact or a number and can commonly be processed using a machine. It can be quantitative, like the number of people who live in a certain area code. Or data can be qualitative, such as user feedback explaining how good the service was today. Data becomes statistics once it is interpreted and given meaning, with the intent to quickly and easily convey the information. However, finding meaning within a dataset can become difficult or impossible without adequate metadata. Metadata is the data about data. Although this may seem complex, good metadata is the key to understanding data by explaining it more fully. A simple example can be found in the metadata attached to the recording of a song. This includes information like the song title and length, performer's name, genre, language, and recording date. Within research data management, README files or codebooks provide overview metadata as well as detailed metadata on a project. These examples could include who was involved in the project, how the files are structured and relate to one another, what column titles mean in a spreadsheet, and what algorithms were used to manipulate the data. Comprehensive metadata ensures that data can be reused and reproduced in the future. From the beginning of the research process until it's time to publish or build upon that research for the next project, good data management is carefully thought through and executed. The National Network of Libraries of Medicine defines research data management as the organization, documentation, storage, and preservation of the data resulting from the research process. Data management should touch each element of the research lifecycle. In fact, the research data lifecycle aligns with the research lifecycle and should help researchers decide how to manage data throughout the entire project. There are a lot of versions explaining the research data lifecycle, but it begins with planning, then collecting, analyzing, evaluating, sharing, and reuse. A final step, or sometimes at the core, is preserving project data. Because data is so prevalent, they can easily be mismanaged. Team collaborations can waste resources during the collection phase when there are no agreed upon data standards. Without standards, combining everyone's efforts can become confusing and time-consuming if information is entered differently. During the analysis phase, visualizations or data manipulations can become lost or need to be recreated if data gets overridden, they were not saved with good naming conventions, or there wasn't any version control. At the end of the project, if storage is not planned for, data can become unreadable when hardware is outdated, proprietary software is obsolete, or the storage device gets misplaced or damaged. To avoid mismanagement, create a plan before you begin. Think through directory structures and naming conventions, document how to perform the analysis, and know how and where to store the datasets and metadata. These are examples of effective ways to manage data. Good management will save time and effort, safeguard against data loss, while also promoting sharing and reproducibility for the scientific community. Throughout the entire research data lifecycle, librarians at Lewis Library can help. We have recommended tools and further education on topics like data management plans, collaborative tools and software, metadata standards, naming conventions and version control, open access, and data repositories. For more specific questions, check out our Research Data Management Guide on the library website or contact a librarian to help. Thank you for taking the time to learn a bit about data.